In this video, we're going to look at the bromination of anisole, or methoxybenzene, molecule shown here. Now, when we add bromine to anisole in the presence of a Lewis acid, like the iron tribromide here, the bromine is going to attack as Br plus an acidic compound. Now, where is it going to attack? Well, we know it's actually going to orthopara, but if you didn't know that, how could you figure it out? Well, one thing you could let Oscar help you by calculating charges. So if I click on Huckle on, auto select, and show charges, what it shows here is that there's a negative charge at the ortho position and the para position. It's not very large, but it's indicative of what's happening here, and indeed is correct in the sense of these are the most basic sites. It's the place where the acid is going to attack. So let me turn this off, and let's draw out a mechanism. So what's going to happen here? Well, the first thing is we're going to utilize the catalyst to turn the bromine into a better acid. So how do we do that? Well, we draw an arrow. We have the bromine, lone pair here, attack the iron. Okay, and we get our first intermediate here, which is this strange looking complex with the bromine molecule stuck to the iron. Now this is going to react with our anisole, so I just need a copy of it over here. I'll bring it over. Okay, and now I could either do the ortho or the para position. Let's do the para simply because it's easier to draw. So the double bond now is going to come around, attack the bromine, kick out the iron tetrabromide anion. So here's our next intermediate, and of course this is our charged now intermediate. There's a proton where the bromine is, and we need that proton in our mechanism because that's what's going to come off. This is, after all, a substitution reaction. So now all we show is that one of these bromides on the iron tetrabromate is going to come over, serve as the base, pluck off that hydrogen, and reform the missing double bond, and this will give us our product if all goes right. So let me draw this down. One last magic arrow, and here's our product. We got our brominated anisole. We get a molecule of HBr and our iron tribromide catalyst back again. So that's pretty straightforward. Just make sure you use the catalyst properly.